This is video lecture number 2 of week 6. In this video lecture, we will discuss Rolle's theorem and the mean value theorem. Of course, there is a kind of what we call connection between these two theorems. Let's see the first one, Rolle's theorem. So what the Rolle's theorem says, suppose f is continuous in the what we call closed interval, that means AB included, differentiable on the open interval where AB is not included. And these are the values of x. So if I put x is equal to a, b in f, I will get fa, fb. And this f and fa, fb must be equal. So that is the important condition of the Rolle's theorem. Then there is a number c between this number, that is between AB, such that f prime c equal to 0. That is, the slope of the tangent at x is equal to c, where c is between AB, is always 0. What do you mean by slope of a tangent is 0? That means the tangent line is parallel to the x-axis. You know that whenever the line is parallel to the x-axis, the slope is always 0. So what it says that for any function f that is continuous on the closed interval and differentiable on the open interval, and if fa and fb are equal, then there must be at least one point between these two where the tangent line to the graph of this is horizontal, means f prime c equal to 0. You see these graphs. 1. So this is the graph of f, right? Then this is the value of x. This is the value of x, that is a, b. So what is fa? Fa is here. What is fb? Fb is here. So that is fa and fb are equal. Then I take C between this A and B, and then I draw a tangent line. So the slope of the tangent line at C is definitely 0 because it is horizontal. Note this, the slope of the tangent line on the left side increasing, positive, on the right side decreasing, negative. But when it is neither increasing nor decreasing, the slope is always 0, means it is a horizontal to the x-axis or parallel to the x-axis. So the same graph, if I draw opening up, again I am taking AB, the graph, and you see this is FA and this is FB. Then I take C between AB, and then I draw a tangent line. Then this tangent line is parallel to the x-axis or horizontal. Therefore, the slope of the tangent line is 0. Similarly, if I draw a graph of opening up and down, okay, so then I have here this is A and this is B. You see here FA is here, FB is here. Yes, they are equal. Then I take one value C1 between AB, then I draw a tangent. You see it is horizontal, again at this f prime C1 is 0. I take another point. As long as between it is AB, it always happens. I take one more point here, then I draw a line. The slope of this, that is f prime C2 is 0. So that's the Rolle's theorem. So be careful that FA is always equal to FB in the Rolle's theorem. Then f prime C equal to 0 for any C between these two. Look at it in the open interval. AB is not included here. So let's see an example for this. So find the value of C satisfying the conclusion of Rolle's theorem. So I need to what you call use the Rolle's theorem to find the value of C for this function, and where AB values are given, which is closed interval. So first what I do, these are the AB, right? That is the value of x. I put x is equal to 0 in this, and I put x is equal to 1 in this. So f of 0 and f of 1 both equal to 2. That is f of 0 is 2 and f of 1 equal to 2. Therefore, f of 0 is equal to f of 1. So therefore, I can use the Rolle's theorem. So what I will do, first I will find the derivative of this. So f prime, it is this. What this says, this is the slope of the tangent line at all x. But I am finding the slope of the tangent at c, right? So I put x is equal to c. So f prime c equal to this. We know that Rolle's theorem says that f prime c equal to 0. Therefore, this is equal to 0. Then I solve this. So this cannot be solved by factorization. So I will use the quadratic formula. So I will get two answers, 1 plus 1 by 3 root 3 and 1 minus 1 by 3 root 3. Then using the calculator, I find the value of C. It is 1.577. So this 1.57 is not in this what you call interval 0 and 1. And as I told you that C must be between what you call AB. So since it is not in AB, therefore this is not the value of C. And I will check the another form, root, that is 1 minus this. Using the calculator I got this. So definitely this C is in this. So therefore the answer is 1 minus 1 by 3 root 3, not this. Although I get two values of C, one value is not the answer because it is not in the interval. Another is the answer because it is in the interval. Similarly, let's see the mean value theorem, the second theorem. Suppose that f is continuous, same, the opening, then there exists a number c belongs to this such that f prime c is equal to this. You see that? What this means? This is the slope of the tangent line at x is equal to c. What is this? This is the slope of the secant line at a f of A, B, f of B. So this is the slope of the tangent line at C. This is the slope of the secant. That means what the mean value theorem says that the slope of the tangent line and the slope of the secant line are equal. So it is just same, except that you see that it is identical to the Rolle's theorem, except that there is no assumption about the values of f at endpoint. So there is no fa equal to fb in the mean value theorem, whereas the left hand side is the same, f prime c. So no fa equal to fb. So left hand side of Rolle's theorem and the left hand side of the mean value theorem are same. On the right side, in the Rolle's theorem, it is 0. In the mean value theorem, it is fb minus fa divided by b minus a. So the expression this is actually the slope of the secant line connecting these 2 points. What the theorem says that, you see, this is my graph, y equal to fx, right? And then you have a, right, b, and then I draw a line. So this is the secant line, right? What is the slope of the secant line? This, fb minus fa, because these are the endpoints. So then what I do for this, what you call a secant line, I draw a, what you call, a tangent at C, which is between AB. So this is the, what you call, slope of the tangent. This is the tangent line, this is the secant line. The slope of the secant line is given by m equal to this. And what is the slope of the tangent line? It is f prime c. And look at this. This line and this line are parallel. Therefore, the slope must be equal. So therefore, f prime c must be equal to fb minus fa divided by b minus a. That's what it says here. So let's see an example of this. Find the value of C satisfying the conclusion of mean value theorem. Here it is mentioned, fx is given and the interval. You see, fx interval is given and C you are asked to find. But this time you are not using the Rolle's theorem, but you are using the mean value theorem. So you can check it. You put x is equal to 0 here. You put x is equal to 2 here. You see f of 0 and f of 2 is never equal because we are now using the mean value theorem. So here it is not equal. So you can check that. Then what I will do, I will find the what you call the slope of the secant at uh, 0 f of 0 to f of 2. So this is f of 2 minus f0 2 minus 0. So this is the slope of the secant line. So I just substitute f of 2 is 3, f of 0 is 1, then I get 1. And this must be equal to slope of the tangent line. So I find the differentiation of this. That is 3x square minus 2x minus 1. Then I put x is equal to c. Then I will get f prime c is equal to this. So this f prime c is this, and this is the slope of the secant line. So this slope of the secant line f prime c should be equal. Therefore 3c square minus 2c minus 1 equal to 1. So this one I bring it on the left, it will be minus 2. So I will solve this. Again, this is not a cannot be factorized, so I will use the quadratic formula. So I will get two values of c, that is 1 plus or minus root 7 by 3. In this case, check 1 plus root 7 by 3, right? Then that value is in 0, 2, therefore that is the answer. But 1 minus root 7 by 3 is not in the interval 0, 2, so that is not the answer. So the only answer is C equal to 1 plus root 7 by 3. Use the calculator. You see this value is between 0 and 2. Whereas 1 minus root divided by 3, the second root is not in this what we call interval. So here we have some exercise. So here you in this example you have to identify which formula you are going to use, whether mean value theorem or the Rolle's theorem, to find the value of C in all these cases. See, you are asked to find the value of C. But how do you know that you are using Rolle's theorem and the mean value theorem? If f of minus 2 is equal to f2, use the Rolle's theorem. If it is not equal, use the mean value theorem. Like that you check it. So this is the answer for that. What we have studied in this? We have studied the Rolle's theorem, examples, mean value theorem, and examples. So that's the end of the second video lecture of week 6. Thank you.